In our next lovely problem of the day, we will be multiplying and dividing two of our lovely functions from the last problem together. So, in our first example problem, it says to find the g times f of x. So this notation, like before, we can rewrite it in a different way, which in my opinion, I think is a little bit easier to understand. So the g times f of x, we can rewrite as g of x times f of x. So I'm just going to be inserting g of x and f of x into the problem where they belong. So let's start with our g of x, which is the 2x minus the 2. And when I insert these functions, I will be writing them in a parenthesis, because when we have polynomials with more than one term, it's much easier to multiply them when we place them in a parenthesis. And I'm also going to be rewriting f of x in a parenthesis right beside g of x, which f of x is up here, which is our 2x squared plus 4x minus 6. Now, I do not have to put the dot in between our two parentheses. Whenever you are multiplying two numbers together, two parentheses side by side mean multiplication. So you can leave the dot off when you multiply these together. So when we multiply these, I'm going to start with my 2x, and what I'm going to do is I'm going to take 2x and distribute it to all three of these lovely terms in the second parenthesis. And then I'm going to do the same thing with the negative 2 in just a moment, so be patient. So let's do 2x times 2x squared. Now when you multiply terms together that contain variables, you multiply the numbers together, or the coefficients, which are the numbers in front of the variables. So 2 times 2 gives me a 4. And when you multiply variables together, you have to add their exponents, which you're like, holy hot dog, Miss Long, this x is missing an exponent. Well, guess what? Whenever a variable is missing an exponent, there secretly is a little 1 hiding out. It's like a secret ninja. So I'm going to add my two exponents on each of these variables together. So 1 plus 2 gives me x to the third. Okay, I'm going to do the same thing with the other two terms. So I'm going to do 2x times the 4x. So 2 times 2 gives me the 8. And x times x, just like before, this x is missing its exponent, so secretly a 1 is hiding out in its spot. So I'm going to add the 1 plus the 1, which will give me an x to the second power. And then finally, I'm going to multiply 2x to my negative 6. So my 2 times my negative 6 will give me a negative 12. And since this one doesn't have an x, I'm just going to drop down the x, because I have no other variables to add my exponent to. Now I'm going to be doing the same thing with my negative 2. Now I'm going to take negative 2 and multiply to all three of these bad boys in my second parenthesis. So I'm going to start with negative 2. Negative 2 times 2x squared will give me a negative 4x squared. I'm going to do negative 2 times 4x, which will give me a negative 8x. And I'm going to do negative 2 times negative 12, which will give me a positive 12. Now, after you multiply all the terms out, you got to combine your like terms. So, whenever you combine the like terms, usually what we do is we start with the term that contains the highest exponent on a variable, which my highest exponent is a 3. So I'm going to start with my 4x to the third term, which I don't see any other x to the third terms to add it to. So it's lonely and all by itself, unfortunately. So I'm just going to drop down my 4x to the third. Then I'm going to go to my term with the next highest exponent, which is this x to the squared term, which it has a match, a negative 4x squared. Now be careful. When we add terms together that contain variables, you only combine the numbers in front of the variable. Leave that variable and its exponent alone. Okay, don't confuse it. When you multiply, you add the exponents together when you have a variable. When you add or subtract, you leave them alone. So 8 minus 4 gives me a 4. And I just leave my x squared alone. Okay, my next highest exponent term are my x terms, because remember, secretly, if I don't see an exponent, there's a 1 hiding out. So my negative 12x minus 8x, negative 12 minus 8 more will give me negative 20. And remember, we just leave the variable alone. so it'll just be an x. And then lastly, my term without the variable is the one we usually write last. And since I don't see any other terms without variables, I'm just going to drop down this lonely 12. It doesn't have anything to add to. I'm just going to drop it on down. Sorry, that's a 2. Alright guys, and that is our final answer. Holy hot dog. That was exciting. Now, the problem on this side is much different than this one, and it takes a lot less steps than the other one. You'll probably like the dividing ones more than the multiplying ones. So on this one, this problem says to find the f divided by g of x, which, like in the previous problem, there's another way to rewrite this notation. So the f divided by g of x can be rewritten as f of x divided by g of x, which fractions mean division, so you can write it as a fraction. So first, I'm going to be placing my g of x in the numerator of my fraction where it belongs. So I'm going to take my f of x from above and place it in my numerator. I'm going to draw my division bar like I have in my problem. And I'm going to write it all over g of x, which g of x is up here. So divided by g of x. And ladies and gentlemen, that is all you got to do on the division problems. Do not overthink the division problems. All we're going to do in this unit is simply divide the two polynomials and leave it alone. In our next unit, we'll be doing more with that, but you'll have to wait on that. Ta-ta for now.